All right, today we're going to be talking about vertex form of a quadratic. You've seen this form before in our parent graphs unit. It's y equals a times x minus h squared plus k. Remember, hk is going to be our vertex, which is our starting point, and a is going to help with our outputs. The name for a quadratic functions graph is a parabola. And then we're also going to be talking about the axis of symmetry, which is a vertical line, x equals h, and it cuts the parabola in half. So let's look at our first example and find a, h, and k. A is -1, h is 1, and k is 4. This means our vertex is at the point 1, 4. Axis of symmetry, we're always going to write this as the equation of a line, so it's going to be x equals and 1, because that was our h value. As you may recall from the parent functions unit, domain is always negative infinity to infinity for quadratics. So let's graph and then we'll look at this other information. So we're going to start at the point 1, 4. And we're going to use our squares. So 1 squared is 1, but because a is negative, we're going to go down 1 instead of up 1. 2 squared is 4, so we're going to go over 2 and down 4. And we're going to continue on using our squares. So 3 squared is 9. And then I'm also going to draw on our axis of symmetry. Because this is an axis of symmetry, that means that our parabola is identical on both sides. So we can just reflect these 3 points on the other side of the axis of symmetry. Then connect our dots to make our parabola. We're always going to use as many points as will fit on the graph paper. So based on this picture, our range would be -infinity to 4 with a bracket. Remember, x-intercepts, solutions, this also could be written as roots or zeros, are going to be where it crosses the x-axis, which are the points -1, 0, and 3, 0. Our y-intercept is the point 0, 3. It increases on the left-hand side of the axis of symmetry, which would be -infinity to 1, and it decreases on the right-hand side, so 1 to +infinity. And then our end behavior, as x goes to +infinity, f of x goes to, and as x goes to -infinity, f of x goes to. Since both arrows are pointing down, we know both end behaviors are going towards -infinity. Let's look at another example. Here, a is 1/2, h is -3, and k is -4. This means our vertex is at -3, -4. The axis of symmetry is at x equals -3. Our domain will always be -infinity to infinity. Let's see if we can figure out the range before we graph it. Since a is positive, we know that the ends are going to be pointing up, so we know our range is going to go towards +infinity. For the y value that we use in the range, we know the vertex is always going to be the highest or lowest point, so the y value for the range will come from the y value of the vertex. We can also easily do end behavior before we graph it. Since a is positive, we know both ends will be pointing up, so both end behaviors are going towards +infinity. Let's graph it so we can get these other 4 things. We're going to start at -3, -4, and And because A is 1/2, we're going to go up half the amount we normally would. So let's rewind for a second. Let's draw our axis of symmetry. We're going to use a dotted line for these because they're technically invisible. So to get our other points, we're going to go half the distance up that we normally would because A is 1/2. So 1 squared is 1. We're going to go halfway up, so just a half. 2 squared is 4. We're only going to go halfway up, so we're only going to go up 2. 3 squared is 9, so halfway would be 4 1/2. 4 squared is 16, so halfway up would be 8. 5 squared is 25. Half of that would be 12 1/2, which won't fit, so we'll stop there. Reflect your points on the other side of the axis of symmetry. And connect your dots to draw your parabola. And make sure you're putting arrows on the end. So our x-intercepts are our solutions here. If you notice, they don't quite cross at exactly a nice whole number or integer point. So we're going to put not exact right here, right now. We'll get to how to find those exactly in a later lesson. Our y-intercept, we know that we went over 3 up 4 1/2. So we know this is halfway, so it's the point 0, 0.5, or 0, 1/2. It's increasing on the right-hand side of our axis of symmetry this time, so we know it's going from -3 to infinity. And it's decreasing on the left-hand side, so -infinity to -3. Now let's look at 2 where we're given the graph and we need to write the equation. First thing we need to find are A, H, and K. H and K are going to come from our vertex point in the middle, which is at 1, 2, 3, 4, -2. We're going to find A by going over one box and seeing how far up that point is, which is 1/2. Then we can plug into our vertex form. Y equals, A comes first, parentheses, x, remember h is going to be the opposite of what it looks like, so -4 squared, and then we're going to put k on the end, -2. And our final example. Go ahead and pause your video and try to determine what A, H, and K are on your own. Hopefully you said A was -1, H was -1, and K is 6. If we plug that into our equation, it'll look like y equals negative, and you can put the 1 there if you want, you don't have to, parentheses x plus 1 squared plus 6. That's all for today. See you in class.